So in this video, I'm going to go over the Unit 9 test review. So let's just dig in. So first of all, this says to solve the log base 5 of 3x plus 9 equals 2. So I can look at this and tell already that there's no way for me to solve this unless I change the form that it's in. So we're going to put it in exponential form. And remember, our base is our base, so this is going to be 5. What is on the other side of the equal sign is what we're going to take it to the power of. And then what we're taking the base of is what it's going to be equal to. So that's always our process, right? So this is going to be 25 equals 3x plus 9. Then we're going to subtract 9 from both sides. So that's going to give us 16 over here is equal to 3x. And then we're going to divide both sides by 3. Now, when you guys were doing the delta math, it asked for an exact answer. And that's what this is right here, okay? So if it didn't ask for an exact answer, but it asked you to round it, then we could say it was 5.333. If it said to the thousandths, that's what x is equal to, okay? All right, here, this one says solve ln of negative 3x minus 6 equals 5. So on this one, we're going to have to do the inverse of ln, which is e, to get rid of the ln. So we're going to take this to the e power. We're going to take this to the e power. So when we do that, this goes away. So then we're left with just negative 3x minus 6 equals e to the 5th power. And you can either turn that e to the 5th power into a number at this point, or you can keep working the problem. So I'm actually going to turn the e to the 5th into a number at this point. So I'm going to turn it into 148 point, and I'm just going to put it 4 decimal places for now because I would just leave this in my calculator, right? So then that's equal to negative 3x minus 6. So then I'm going to add 6 to both sides, right? So that's gone now. And so I'm left with negative 3x equals, that would be 154. Again, I wouldn't change this in my calculator. I would just add the 6 to it, okay? And then we're going to divide by negative 3, both sides, okay? So when we do that, x is going to be equal to negative 0.471. Okay, so now I want you guys to see what it would look like if I did it just like this. E to the 5th plus 6 divided by 3, right? I could do it that way as well, okay? All right, on this next one, the first step, again, is that we're going to divide by that 12. It says to solve again, so we're going to do that first. So we get e to the 3x plus 2, that equals 5. How do we get rid of an e? We take it to the ln, because ln's the inverse, right? So that's how we cancel it out. So then this again, those two cancel each other out, so we're left with 3x plus 2 equals the ln of 5. And again, we could leave that ln of 5. But for my sake, I'm going to go ahead and put a decimal there, 1.6094. Then we're going to subtract the 2 from it. That's going to give us 3x equals negative 0.0390. Sorry, I did that wrong. So it's 0.3906. And then we're going to divide both sides by 3. So our x is going to be equal to negative 0.1302, which if we rounded this, it would just be 130. So if it said to 3 decimal places, we'd stop right there, okay? So here again, we could do the ln of 5, right? Minus 2 divided by 3. We could put it in the calculator just like that. That's what x is equal to, okay? So on this one, the first thing we have to do is we have to take this and make it an exponent, okay? We're going to condense it first. So that's going to be your first step, is to condense it, okay? Then we're just going to have ln of x minus 5 is equal to ln of 4 to the 3rd. Well, we could do the inverse on both sides of this e and e, which would cancel that out, but we could also see that it's on either side of the equal sign, so it's going to cancel itself out. So that's going to leave us with x minus 5 is equal to 4 to the 3rd, which is 64. So then we're going to add 5 to both sides. So x is equal to 69. And again, remember, you can put these back up in and check them, okay? So now, again, our first step is going to be to condense, okay? That's going to be our first step. So we're going to do log base 5 of x plus 4. And hopefully you remember if there's a plus here, we're going to multiply this term. Okay? So that's going to be equal to 1. So this is going to be log base 5 of x times x. That's x squared. 4 times x, that's 4x. And that's equal to 1. So now we're going to put it in exponential form. So that's going to be 5. That's our base, to the 1 power. What's on the other side of the equal sign? And then that equals what it was of. So this is going to be x squared plus 4x. So on this one, we're going to move this 5 to the other side, right? So we're going to subtract 5. So it's going to be x squared plus 4x minus 5. So this is going to give us 0 over here on the left. So this is going to be 0 equals x squared plus 4x minus 5. Now we got to factor that. So we're going to have x and x. What are the factors of negative 5 that when added together give you positive 4? So that would be plus 5 and minus 1. We're going to set both these factors equal to 0. So we're going to set this one equal to 0. So x is going to be equal to what? Negative 5. And over here, x minus 1 equals 0. So x is equal to positive 1. So now remember, when we get a negative number down here, we need to check it, okay? So if we put a negative 5 here, that's going to give us a negative 1 in this parenthesis, right? Well, and over here, even if we put a negative 5 there, then we're going to be taking the log of a negative number. Remember, we cannot take the log of a negative number. If you did that in your calculator, you get an error. So that's an extraneous solution. Now, when you put in the 1 up here and the 1 there, you're going to see that log base 5 of 5 is 1, right? Log base 5 of 1 is 0. So this would work out. This would end up being 1 plus 0, which equals 1, okay? When you put the 1 up there, okay? All right, so this one, again, the first step is going to be to condense, okay? So whenever you have a plus or a minus here between two logs, you want to condense it first. So we're going to say log base 7 of 10. And this time we have a minus. Y'all see that? So that's division. Okay, so that means we're going to do x minus 2 here. Okay, and then that's going to be equal to log base 7 of 23. If you remember, if we have the same log base, then whatever those two things are of, we could set those equal to each other. So we're going to set this equal to this because these two can cancel each other out. So we're going to end up with 10 over x minus 2 is equal to 23. How do we get rid of that x minus 2 in the denominator? We multiply both sides by it. Okay, so that means this and this cancel out. We're left with 10 over here. So this is going to be 23 minus 46. And 23x, sorry, minus 46. Then we're going to add 46 to both sides. So we're going to end up with 56 is equal to 23x. Then we're going to divide both sides by 23. So my answer can be x equals 56 over 23 if it's asking me for an exact answer. Or if not, it's also equal to, if I round it, 2.435. Okay? All right, so this one says solve without using the change of base and only use inverse properties. So that means I want to have the same bases. So I want to have log base 9 of 9. So the real question is 9 to what power is equal to 1 over 729. So what I want to figure out first is 9 to what power is 729. So when I start taking 9 to powers, I'm going to take it, well, obviously 9 to the second is 81. So 9 to the third is actually 729. So if I want to figure this out, I'm going to say 9 to what power is going to be the negative 3, okay? So that's going to go right here. So how do I know that? Because if I put 9 to the negative 3 in the calculator, I get 1 over 729. And 9 to the third is 729, okay? The 1 over means it's negative. So here again, I want you guys to see what this really means. Log base 9 of 9 is equal to 1. And then it's 1 times negative 3. So our answer is negative 3, okay? Which is what is the exponent right there. And that's how we solved this without the change of base. You need all of this to show me that you solved this without the change of base using the inverse properties, okay? So this says find the domain and range and end behaviors of the functions using the graphs, okay? So we want to find the domain and range. So the domain of a radical is always going to be x is going to be greater than, less than, or equal to some number, okay? So we want to look at what this number is right here, okay? That number right there is the beginning part of our graph, and then the graph goes off to the right, okay? So as we're looking at our x values, where do our x values start? They start at, what is this number right here? 2. So we're going to say x is greater than or equal to 2. And as we talk about our range values, again, we're going to talk about our y values. So where do our y values start? They start at 5. So our y is going to be, and again, it's going up as well, right? So it's going to be going greater than or equal to 5, okay? So as x approaches infinity, so as we go this way on the graph, what's happening to our y values? What's happening to the graph, y'all? Isn't it going up? So that means we're approaching infinity here. Now, it says as we go towards negative infinity here, that means we're going this direction. What happens to our y values? Look at that. What happened? So on this one, it's going to obviously go to where our y value is right there on our graph, which is 5, okay? So we're going to put 5 here. So notice this connection. Do y'all see this connection right here? Because remember, this means y, right? Okay. So let's do another one. This one says find the domain and range and the end behaviors of the function using the graph. So again, here's the starting point of our graph, right? So we have an x value of -5 and we have a y value of -3. Do y'all see that? So what's happening now as for the domain? What's happening with the x values? Are they getting bigger or smaller as we go on our graph? Looks to me like they're getting bigger. So we're going to say x is greater than or equal to that -5 over there. Our range, now that's our y values, right? So we're going to be moving on our graph down towards the right. Where did our y values begin? So our y values are going to be less than or equal to, because the graph's going down, -3, okay? That's this value right here, okay? So as x approaches infinity, so again, as we move this direction on the graph, what's happening to our y values now, y'all? Where's this graph going? Isn't it going towards negative infinity? And as x approaches, so as we move this way on our graph, where does it end, y'all? Where does the graph end? It ends right there. Y'all see that? So what value is that? Our y value. What's our y value right here, y'all? Yes, it's -3, okay? And again, see this connection right here between these two? That's pretty important. All right, so now this one says find the end behaviors of the function. So we're going to look at these on Desmos. So I'm going to go ahead and put this equation into Desmos, and it is y equals -4. I'm going to go down here and get my square root symbol, which is right there, of x minus 5. So there's my graph. I'm going to go to close this so I can see the graph. Okay, so there's the graph. And oops, I forgot to put a plus there. So it's -4 plus, right? So let's put plus. Okay, so now again, do y'all notice this graph has a starting point, right? So the graph starts at -4, 5. And that's connected to here. Y'all notice that? -4, 5, because we could move this -4 over here and it would be -4, okay? So that would be our h and our k. So when we're looking at this graph, again, it's asking us about our end behavior. So as we move towards the right, where's the graph headed, y'all? Yes, it's headed towards infinity. And as we move towards the left, where's the graph headed? This time as we're moving to the left, where's it headed? Isn't it headed towards -4? Okay, so remember, we're talking about the y values and we're talking about end behaviors, okay? So let's go back to our answer. So as we were going right on this graph, it was going towards infinity, and as we were going left to this graph, it was going to -4. So let's look at this next one again on, so here's our graph of 1/3 of the square root of x plus 1, and again, our starting point here is at -1, 0. Our graph is going to go up and to the right. So as we head towards infinity, it's going to be positive infinity because our y values are going up. And as we head towards the left, where are we going to end here? Notice it's at -1, okay? I think I put 0 for that. No, that's y value. It is 0. Yep. So we're looking at the 0 value. Yep. So let's go again over here and write our answer. So again, as we're going towards the right, it's going towards infinity, and as we go to the left, it's going to be at 0 because that was our y value, right? All right, here's the third one of these. So here again, when I put this into Delta Math, into Desmos, this is what I got. And again, remember, we're looking for our y values here. So as we head towards infinity, where we headed, there would be an arrow here. So this is headed towards negative infinity. As we head towards the left here, towards negative infinity, where's the graph headed? It's headed towards, what's this value right here? Y'all see it? This value right here is at 7, right? So as we head this way, we're headed towards negative infinity. As we head this way, we're headed towards what? 7. Okay? Again, let's go back here. So as we head towards positive infinity, we were headed right on this graph, we were going towards negative infinity. And as we were headed left on this graph, we were headed towards 7. Okay? So it says find the inverse of the function. So this is what I'm going to actually say this is y is equal to 3x minus 2. And I'm going to swap my x and y. So this is going to be x is equal to 3y minus 2. We're going to take this now and we're going to put it in log form. So this is our base. So we're going to say log base 3 of what's on the other side of the equal sign, which is x. That equals our y minus 2. So then we're just going to add 2 to both sides. So f to the negative 1 of x is going to be equal to log base 3 of x, and this is in parentheses, and then we're going to add that 2 outside of there. Okay, so remember that if we do something after we put it in log base form, then whatever we do to it afterwards is going to stay outside of what we're taking the log base of. Okay? So once again, remember this is y right here, so I'm going to go ahead and swap it. Okay, what will be my first step here? Hopefully you see it. We're going to subtract that 1, right? Whoops. So we're going to subtract 1 from both sides. So this is going to be x minus 1 equals 5 to the y power. Now we're going to put it in logarithmic form. So there's our base. So it's going to be log base 5 of whatever's on the other side of the parentheses. So that's x minus 1. And this is going to be our inverse because that was all we had left over there was the y. So this says Elijah just bought a new iPhone 12 Pro and it cost $990. The phone will depreciate at a rate of 11% per year. Write the equation, find the value of the phone after 3 years. So our equation is going to be the A equals whatever we start with, and we could call it the principal. 1, and this time it's going to be minus, because it's depreciation, our rate of interest to the power of our time. So we want to go ahead and put in here our starting value, which was $990. And then we're going to do 1 minus our 0.11, and then after how many years? 3 years. Okay, that was our t right here. This was our r. This was our p. Now I need y'all to listen. Okay, so be really careful with this. If the problem says depreciation, then that means that this is a minus. Okay, that's really key for you guys when you're doing these problems. So go ahead and just plug that then into the calculator, and when you do, you should get $704. And y'all, also when you're writing these answers, you should do them to the cents, right? Because that's how we deal in America anyway with cents. Okay. All right, 16 says evaluate without using the change of base formula. Okay, so everybody needs to watch me here. 5 log base 5 is equal to 1, okay? So that's going to be 1 times 31, which is what? 31, all right? Now up here, we're going to subtract from it. Now what we want to do here is we want to get log base 8 of 8, because again, that's going to be 1. So what we're looking for then is 8 to what power is 4096. So you could do 8 to the second, which would be 64. You could do 8 to the third. And actually, what you're going to find is this is going to be 8 to the fourth. Okay, so what is this? This means log base 8 of 8 is 1 times 4, and that's equal to 4. Okay, so then we're going to subtract the 4 from the 31, and that's going to give us 27. Okay, so make sure you know how you get to here and how you get to here. Okay, you're going to have to show this part and this part. Okay. All right, evaluate using the change of base formula. Now this time we get to use the change of base formula, and I told you how the base stays in the basement, right? So we're going to put log base 6 or log of 6 in the bottom, and we're going to put log of 45 on the top. And then we're just going to divide those two by each other. And when you do that, you're going to get 2.12 is what I got. Okay? All right, when we find the inverse, again, remember this is y, so we're going to make that x. X is equal to ln of 9y plus 7 minus 1. So our first step here would be to add 1 to both sides. It's going to give us x plus 1 equals ln of 9y plus 7. So we want to do the inverse of ln, which is, hopefully you know, e. So we're going to take both of these to the e. So get e to the x plus 1 equals, now that's gone from there, so we're left with 9y plus 7. So our next step would be what? Yes, subtract 7 from both sides. So now we have e to the x plus 1 minus 7 is equal to 9y, and our last step would be what? Yes, divide by 9. So our answer is going to be f to the negative 1 of x, that's the inverse, is e to the x plus 1 minus 7 all over 9. So this problem says, how long does it take for an investment to double at an annual interest rate of 7.25% compounded continuously? Okay, so this tells me our formula is going to be A is equal to P e to the RT power. That's the compounded continuously formula. So it says we want our investment to double, right? So our original investment is P, so if we want it to double, it's going to be 2P, and that's going to be equal to our final amount, which is A. So we're going to put 2P here, and that's going to be equal to PE, and then our interest rate here is going to be 0.0725 to the T power. Well, hopefully you see that we can divide both sides by P. So it's going to leave us 2 over here equals E to the 0.0725 T. Now we need to get rid of that E so that we can just deal with the T, right? So the inverse of E is ln, so we're going to take the ln of both sides. So that's going to leave us with ln of 2, and then that's going to be equal to 0.0725 T. We could divide both sides by 0.0725 right now. And in our calculator, do the ln of 2 divided by 0.0725. Okay, and what that would have been is, let me find my paper, 0.06, sorry, 0.6. This is about what it was, and then we would have divided that by 0.0725, and that's going to equal T equals 9.56 years if I were to give it to the 100th, okay? All right, so the last one says Thomas invests $5,500 in an account that pays 7.25% interest per year, and this one is also compounded continuously, which was not. Yeah, it'd be great if I could spell, y'all. Okay, so that means, again, we're going to use the formula A equals P e to the RT power, right? So it says Thomas invests $5,500 in the account, so that's going to be our P, right? 5,500. That pays so this is going to be E. The rate's going to be 0.0728, because this is, again, our R, right? This is going to be our P. Now it says how many years will it take the investment? So we're actually going to look for T to be worth $11,000. So we're going to put our 11,000 over here. So this time we're going to divide both sides by 5,500. Yeah, it'd be great if I could write today, huh? So that's 2, and that equals E to the 0.0728 T power. How do we get rid of an E again, y'all? We do the ln, right? So we're going to have the ln of 2. Ln of 2 is equal to 0.0728 T. So again, what are we going to do? We're going to divide both sides by 0.0728. 0.0728. On your calculator, if you do the ln of 2 and divide it by 0.0728, T is going to equal 9.52 years again. Okay?